Hi everyone. We're going to find the x values, if any, at which f is not continuous and which of the discontinuities are removable. And I think it helps to look at the ones that are continuous and the ones that aren't continuous. The first set I put are these 5 problems here. Now all of these are continuous for all real numbers. This upside down A means for all. So for all x that are real numbers. And when you're looking at this, we see that these, you know that this is, the first one is just a quadratic. It's smooth. There's no holes, which is what we're calling discontinuities in calculus. The rationals you have to, ones you have to worry about. So for example, these two right here, you would probably have to look at that and look at the domain. If you look at this and set this to 0, you're going to get x squared equals -1. So x equals plus or minus square root of -1, which is plus or minus I. But we're not talking about complex numbers. So in this case, there would be not continuous here, but we're not talking about the complex numbers. So this would be the domain is the complex numbers. We're only talking about the real numbers. So for all these problems, these are all continuous for all real numbers. Now the second set is where we're going to have some discontinuities. So if I look at this first one and I rewrite it, factor out the x, what we're going to say is that it's discontinuous, or it's not continuous, at x equals 0 and x equals 1. So it's not continuous. That's just like when you did your domain. And also, on this one, we have a 1 or a 0. Where is it? Okay. X equals 0 is a removable discontinuity. And the reason, then, that means that when you're graphing it, it has that hole. So basically the reason it's a removable discontinuity is because this can cancel and you would get 1. Okay, but the 1 doesn't cancel out. Okay, so the same thing's going to happen for this one. It's not continuous, or x is not continuous, at x equals 1 and x equals -1. Because I can factor out the denominator as x plus 1 and x minus 1. I just did opposite. So it's not continuous there. It does not have a removable discontinuity because there's nothing we can cancel from the numerator with the denominator. Okay, the next one is the same thing. We have x equals 3 and x equals -3. This not x is not continuous. I can spell because you can factor this as x minus 3 times x plus 3. It does have a removable discontinuity because if I rewrite this, x minus 3 over x minus 3, I was going to put this in parentheses, x plus 3. These cancel. So it does have a removable discontinuity at x equals 3. Okay, Now the next one we have is this one. I'm going to go ahead and factor it. This would be x plus 2, and then we're going to have x plus 2 times x minus 5. So that's your f of x. That means x is not continuous. Or we can just say it has a non-removable discontinuity at x equals 5 and a removable discontinuity at x equals negative 2, because I could cancel those out. These were like, if you pre-cal, it would be considered a whole because you can cancel that out. And the same thing for the last one. Let's factor out. Let's just rewrite this, and we're going to get x minus 1 over x plus 2 times x minus 1. So it has non-removable discontinuity at x equals negative 2, and it has a removable discontinuity at x equals 1, because you can cancel those out. Okay, the next set I'm going to do involves piecewise defined functions, including the absolute value function. Thank you. Have a nice day. Bye-bye.